All right, so you were introduced to a matrix in your warm-up. This is a matrix is a rectangular array of numbers. The plural matrix is matrices. The matrices below represent the t-shirt inventories at 4 different stores. So looking at store A, B, C, and D, what describe the matrices? How are they similar? How are they different? What did you just observe? What do you see? Yes, Cordelia. All right, they all have small, medium, and large. Good. So they have the same like sizes on the side. What else? What's up?
They all have short sleeves and long sleeves.
Short sleeves and long sleeves. Good. What's different? You told me what's the same. What's different? The actual numbers inside. Yep. Some of them have sleeveless and some of them don't. Right? So, looking at the small, medium, large, how would you categorize that? Like, what word would you give that? They all have the same what? Yes. But if we're talking about, like, what part of the dimension would those be? Okay, length and width. Think of other words for that. A column or a row. Yes? So do we agree that they all have the same rows, like category for rows, the small, medium, large?
Yeah.
Yeah? But store B and store D have an extra column for sleeveless? Yes? Do you agree with those observations? Okay. So they all have 3 rows, right? That's the small, medium, large that we observed. Store B and store D have an extra column for sleeveless. B and D have a sleeveless column. All right, so using those words, how can we describe the dimensions of each matrix? What do you think? How would we describe a dimension of something or the size of something? What? Like a 2 by 3 or a 3 by 2, right? If you ever have to buy, I don't know if any of you have to go buy like lumber at Home Depot. If you build something and you wood typically comes like, have you heard of a 2 by 4?
Yeah.
Have we heard of that phrase? A 2 by 4? That's 2 inches by 4 inches, right? That's what those numbers are representing. Okay. So they're representing the height and the width of that piece of wood. Dimensions of our matrix describe the same thing. Okay? So if I tell you that store A is a 2 by 3, I lied. No, it's not. If store A is a 3, come on. My pen is not having a good day today. There we go. A 3 by 2. Store C is also a 3 by 2. How do we usually do dimensions? Is it columns by rows or is it rows by columns? There you go. We're going to do rows by columns. Okay. How would we describe store B and store D? What's their dimension going to be? 3 by 3s. Okay. And they get a special name. If your rows and columns are the exact same, what do you think a special name might be for that? A square. Yeah. These are square matrices. Good, yes. So if your rows and columns are the same, then they're called square matrices. Something my teacher taught me way back when to remember that it's rows by columns. There's a soda called RC Cola. Have we heard of it? Have we seen it? Maybe. Well, if you don't know, there's a thing called RC Cola, and that's just always stuck in my head. Rows, columns, RC. So, all right. So we've kind of played with matrices. Let's do some more vocab with them. Okay. So, summarize. A matrix is a rectangular array of numbers. Okay. The dimensions of the matrix with m rows and n columns are read m by n. So the dimensions of matrix A, and it's referring to this guy right here, the dimensions of matrix A are a 2 by 3. Okay? The numbers inside of the matrix, that -1, that 5, that 3, okay, these are called elements. All right? Two matrices are considered equal when their dimensions are the same and the elements are the same. I know, right? If you use any outside resources, elements can also be called entries or positions. Okay, so if you use anything else, those words typically correspond to each other. Dimensions and then the size of a matrix are referring to the same thing. Right? Yeah, so are we okay with matrices? Yes, if you ever go into any kind of coding, by the way, like animation or websites or anything like that, some coding, the original coding was all matrices. So like it is used in the world if you're interested in that field. I think A Bug's Life was made solely on matrices. Or it was one of the first ones to use it. So, pretty cool. Here we go. So we are going to play with adding and subtracting first. Okay? To add or subtract two matrices, we have to add or subtract their corresponding elements. Okay? And we can only add and subtract matrices when they have the exact same dimensions. Okay? Because I can't, if they have to be in the same spot for me to add or subtract, and someone has an extra row that the other matrix doesn't have, I have nothing to add it with. Does that make sense? It does not exist. Okay? 0 would be an entry. So for it to just not even be there, I can't use it. So they have to be the exact same size for me to add or subtract. Okay? All right, so here we go. First one. What are the dimensions of my first matrix? A 2 by 2. What are the dimensions of my second matrix? A 2 by 2. Can I add these together? Sure can. And that thing's called a 0 matrix. It has a name. It does get used. It is special later. Okay? But this is called a 0 matrix. A matrix filled with zeros. So let's add them. So if I'm just adding a 0 matrix, does anything change? Nope. All right? You do B, if you can. Yeah. Always figure out if you can do it before you actually do it. Okay? All right, Jada, what are the dimensions of the first matrix in part B? 3 by 2. Good. We got 3 rows and 2 columns. And if you're confused on which one is which, I always think columns are things that hold up a house. So if that helps you remember, columns are vertical. Okay. What's the size, Jerry, for the second matrix? 3 by 2. So Jordan, can I subtract these together? Yes, we can. Charlie, what is my first row of numbers? Yes, there you go. Yeah, it is. Julian, what is the next one?
-2 minus 4.
Yep. -2, -4. So 3, -5, -2, -4. They're each their own element, right? Jacob, last one.
3 and 2.
Good. All right, good. So the only thing that might have happened, remember subtracting a negative just means adding. So if you got some of those mixed up, that might be what you forgot to do. All right? Yeah? Taylor, what are the dimensions of my first matrix in matrix C? Yes. Kennedy, what about the second matrix? 2 by 2. So Isaac, can I add these together?
No.
Are they the same? Nope. Nope, this one is not possible. Not possible. Okay. Dimensions are different. Good. We feel good about adding and subtracting?
Yeah.
Can we move on?
Yeah.
Great. All right. We are going to move on to our first type of multiplication, okay? We can multiply matrices with each other. That's tomorrow, okay? Today we're going to do scalar multiplication, okay? You might have remembered that word, scalar. Do you remember that from like maybe vertical stretches and compressions? We had a scalar factor. Maybe? No, never heard that word? Okay. Well, a scalar multiplication is when you just multiply by a number out front.
Oh, okay.
It's just distributing by multiplication to each piece. Okay? So in operations with matrices, numbers are usually referred to as scalars. In this text, scalars will always be real numbers, so we're not going in the imaginary world. Okay? To multiply a matrix by a scalar, we just multiply each matrix, each element in the matrix by the scalar out front. Okay? So we just apply it through everything. Something else to take note and keep in mind, okay? If A, B, and C are matrices with the exact same dimensions, okay, my adding, right, it doesn't matter the order. So the associative property still applies, and the commutative addition property applies. So adding, we can go back and forth, okay? Subtraction order still matters, right? And then our distributive property also applies with a scalar multiplication. That will be different tomorrow. So that's why they're bringing it up today. So, we got this. I have 2 times the matrix 3, -2, 1, 5, and 2, 0. All right? Aiden, what you got for me? What's the first column? Just multiply each piece by 2. So like the dimension, yeah, this is going to be a 3 by 2. So I want you to actually multiply. So what is 2 times the first column, that first vertical line of numbers?
6.
Yep.
2.
Mm-hmm. There you go. Good. David, how about my second column?
-4.
Mm-hmm. There you go. Yes. Uh-huh. We good? Still easy? Yes. We okay? All right, moving on to part B. Part B, I have some scalar multiplication and some adding together. Which one are we going to do first? Yeah, so order of operations are still a thing. They're still a thing, okay? If I had parentheses right here, I would add first, right? And then multiply. Those don't exist. So let's distribute the -3 to just the first matrix that we have. Chandler, so what is our first matrix going to look like? What is it? All right, Chandler, so help me fill in this first matrix. Mm-hmm. Mm-hmm. There you go. Good. All right, so multiply, and now we're going to add across. Dion, help me add. Mm-hmm. 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 There you go. Good. Still feel good about it? Yes? Okay. You're in for a rude awakening tomorrow. Just saying. It's real fun. All right. So now we can use this to start to solve, okay? There's a couple ways to solve. The first way we're going to use is using the matrix equality. So if I have a matrix equal to a matrix, I can use that information to find missing variables. Okay? So we're not solving for a whole matrix. That's later. This is just solving for pieces of a matrix. Okay? So we are going to set it up so they have to be the same size. 2 by 2, 2 by 2, we're good to go. So each entry matches with another side. Okay? Right away, I know A equals 4 because they're in the same position. Right? They're both first row, first column. So I got that one. A equals 4. Which other one kind of stands out to me? Yeah, B equals what? B equals -7. Okay. We're going to need a little work to find C, but not too much work. So 2C equals 8 because they're in the same position in our matrix. So C equals 4. And then D plus 4 is in the same position as 6. So D equals what? D equals 2. Do we get the concept? Does that make sense? Ready to level up?
Yeah.
It's time. Yep, we are going to level up. I want to make sure you have a second to get this down if you need it. Part B has some more stuff happening, right? A little bit more involved in Part B, okay? I see parentheses. I see a scalar. There's not just a matrix equal a matrix. I have to simplify the left side and make it a matrix equal a matrix before I can find our missing variables. Okay? Yeah. So if you write large, leave enough room to do two sets of matrices, if that makes sense, below this, okay? Because I'm going to add first, and then I'm going to multiply by 4. So give yourself room to put 2 more columns down here. All right, so because it's in parentheses, we are going to add first. So -2a plus 3, well, that's just -2a plus 3. Nothing crazy, right? Below it, -4 plus 7c, well, that just stays... Zoom in. -4 plus 7c. And then I can do 5 plus -6. That's just 5 minus 6, which is -1. And then 2 plus 1 gives me 3. -28. 40, B, and D. Okay, so we can't do anything yet. I can't say B equals -1 because I'm not done with the left side. The last thing we have to do is multiply the whole thing by 4. Okay, so 4 times -2a plus 3, you just multiply each piece by 4. So -8a plus 12. We got this, right? Lewis, what's underneath that? 28c minus 16. If you have -16 plus 28c, are you wrong? No, you're not wrong. Okay? He just switched it up so it was in the mathematically correct order. Okay? So if you have... This is fine. You could also have -16 plus 28. Same thing. Let's see here. Sonia, How about my last column? Beautiful. All right, so now I have a matrix equal a matrix of the same size, and now we can get our A, B, C, and D values. So I'm going to stop. You're going to find them. Ready, set, go. All right, what is the value of A? Anybody? 5. How about the value of B? -4. I heard it over here. I believe it was Addison. Good job. How about C? 2 and D. 12. Which one of these were just given to you? B and D were just given, right? We had some work to find 5 and 2. Do we need to see any of that? Or do we know where 5 and 2 came from? All right, so for 5, so my A, -8, A plus 12 was equal to -28. So you subtracted 12 and then divided by -8, and that's where 5 came from for that one. And then for your C value, you did 28C minus 16 equals 40. So you added 16 to get 56, divided by 28 to get the 2. All right. Ready for our real world problem? We do. It's track and field season, right? It is. We got to do a track and field problem that matches with what's happening. Here we go. That was funny. Good one, Noah. All right. A high school district track and field organization used the same standard qualifying times for its district championships in 2 consecutive years. The tables show the number of boys and girls in 3 class levels who qualified in the 100-meter run in those years. Organize the data using 2 matrices, one for each year. Then find and interpret a matrix that gives the average number of boys and girls who qualified in each class. Okay? So right now they're organized by boys and girls, right? They want me to create matrices for each year. Okay? So we're going to reorganize these matrices because it says, where is it? Organize the data, 2 matrices, one for each year. So we're going to do a 2019 matrix and a 2020 matrix. Okay? So we'll call matrix A the 2019 matrix. Okay? So we're going to set it up boys, girls, and class 1, class 2, and class 3. This is how matrix A is going to get set up. Okay? So how many boys in 2019 were in class 1? How many boys were in class 2? And how many boys were in class 3? 16. So we pulled these values, right? In 2019, how many girls were in class 1? 21. How many girls qualified in class 2? And how many girls qualified in class 3? 24. Good. All right, can you make the matrix for 2020? So we'll call matrix B our 2020 matrix. So make your matrix for the year 2020 of the qualifying boys and girls for each class. Trevor, give me the boys. Good. Chris, can you give me the girls? Yes, good. Yeah, we good? So make sure you read, because if you just took the tables and made each of them into a matrix, you would be wrong, right? Because what they gave you was a girl matrix and a boy matrix, and they wanted you to have the matrices for each year. So make sure you do read on how it wants you to use the data that's given to you. Okay? So now that we have a matrix for each year, it wants us to find the average number of boys and girls who qualified in each year. Okay, so how do we find the average of something? You add them and divide by how many you got, right? So for this one, yes, we're going to add A and B. We're going to matrix A, add them together. And in the world of matrices, we don't divide. We don't divide by numbers. We don't divide by matrices. It's not a thing. Okay, so what can I do instead of dividing by 2? Use a scalar multiplication of 1/2. All right, so we're going to do 1/2 of, oh, that matrix is not big enough. Matrix A, which is 18, 23, 16, 21, 22, and 24. And we're going to add to that the matrix B that we made, which was 16, 25, 12, 15, 18, 18. I'm going to go under it. All right, so am I going to do 1/2 first, or am I going to add first? We're going to add first. There we go. Jonas, can you give me this matrix? Almost. Yep. You're good. Keep going. Yes. Good. Francesca, I don't think I've called on you yet. Can you give us our final answer? You're good. I know. I called on you too fast. Yeah, just do 1/2 in each number. Mm-hmm. 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 Good. All right, so we have our answer, but what does it mean? Okay, so remember how we labeled the years? What did we put on top of each column? We put boys and girls, right? And then what do we put across the sides? Class 1, Class 2, and Class 3. So because they were set up the same way, they are equal matrices, right? Our answer matrix is representing the exact same categories. Okay? So we can say, over the 2 years, Class 1 had an average of how many boys? 17 boys and 18 girls qualify, right? Class 2 had an average of what? Anybody? 24 boys and... Kale, what do you think? 24 boys and how many girls for Class 2? Yeah. Eli, how about Class 3? Beautiful. 14 boys and 21 girls. So make sure you know what your math is representing, especially with matrices, because they are representing something, okay? Does it kind of give you a sense of like two-way frequency tables? A little bit? So kind of the same concept there. We're just making them into matrices and we get to do operations with them. Yeah? Good job.